Next we're going to look at coterminal angles. So what I like to do first is I like to break up that word. Co. If you live in a community, then it's people working together. Or if you're a co-captain of something, that means it's you and someone else. So I like to think of co meaning same or together. And then terminal, well, every angle is made up of an initial side and a terminal side. Terminal being the ending side. So really I think of coterminal angles as same ending angles. That's how I like to think of the word coterminal, because they're angles that start and end at the same place. That's not saying that they start and end like that. It's saying that if you've got one angle that starts at its initial side and ends at the terminal, there's potentially another angle that will start at that initial side and end at the same terminal side. So same ending angles are going to be those coterminal angles. You may have gotten the idea of it from here, but let's go ahead and take a look at an official one. So I'm going to go ahead and start off with just a regular old 45-degree angle. Nothing fancy about it. If we start at the initial side and we go up to that 45-degree angle, we've got the initial side here and the terminal side here. But as you saw before, I could also start at this initial side and wrap clockwise around, giving me a negative angle. And if you watched the previous video on how we found the measure of an angle, then you'll know that you can go negative 90, negative 90, negative 90, and then an additional 45, which brings us to a 315-degree angle. But there are so many more coterminal angles around here. I could start at standard position, pass over that 45, and then come all the way back around to it. In which case, I'll have gone 360 degrees plus an additional 45, bringing me to 405-degree angle. And I can always continuously spin more and more and more. So the secret to coterminal angles is for you to take that angle, so whatever measure your angle is originally. So let's say the 45. If we take our angle and we either add or subtract a full circle. Because you can look here and you can see it. Once it's drawn out, you can do that measure of an angle that we looked at in the last video. But what if we're just given the number? Let's take a look at that. If we're given 138, you can draw it out and you can try and figure out all those different measures of the angle. But if you think back to what I wrote up here, angle plus or minus a full circle, if we take that 138 and we add a full circle to it, then we should get a coterminal angle. 138 plus 360 is going to give you 498 degrees. So that is a coterminal to 138 degrees. These are both angles that will start in standard position and end at the same terminal point. And if we subtract a full circle from it, then we'll take 138 subtracting 360, we end up with negative 222 degrees. Again, coterminal angle to it. All of these guys here are coterminal angles to each other. And I can keep adding more and more circles or subtracting more and more circles. So if I take 498 degrees and I add another full circle, then I can end up with one more coterminal angle. And you'll see how this stuff can get out of hand pretty quickly. Technically, there are infinite number of coterminal angles because I can always add more and more and more circles to it. You can always spin again, or you can always spin in the other way again. So I could take away 360 more degrees over and over and over until I get a ginormously negative number. And it doesn't matter. Coterminal angles, there are infinite of them. So let's take a look at what happens if you've got radians, because radians tend to freak people out as well. A lot of times when I introduce it with degrees, people say to themselves, to find a coterminal angle, you add or subtract 360 degrees. But notice that's not what I said and that's not what I wrote down. In order to add a full circle, all you have to do is make sure that the units are correct. So a full circle in radians is going to be 2 pi radians. So I need to either add or subtract 2 pi. And this is where people get uncomfortable, because they've forgotten how to add or subtract fractions. And the secret to it is to make sure that you find that common denominator. So we're going to multiply by 5 over 5. And in case you've never thought about it, the reason you're allowed to do that is because this is technically equal to 1. You're tricking the problem into thinking that it's different than it actually is. You're always allowed to multiply by 1. That won't change the problem. So that means when we look at this, we end up with pi over 5 plus 10 pi over 5. Again, technically we never changed the problem. All we did was multiply by 1. We just made it look different than it actually is. When you're adding or subtracting fractions, you keep that same denominator. So we keep our 5, and then you either add or subtract depending on what the sign is. Pi plus 10 pi, well, everyone freaks out with those pi's. But if I have 1 pi in my hand and then I have 10 pi's in my hand, total I have 11 pi's. So 11 pi over 5 is a coterminal angle to pi over 5. And again, we can reverse that. Instead of adding a full circle, we can always take away a full circle as well. If we do that, we need to make sure to keep that common denominator, because again, all you're doing is multiplying by 1. It doesn't change the problem at all. And in this case, we're subtracting that 2 pi. So if I have a pi and I take away 10 pi's, I'm left with negative 9 pi over 5. And again, just like with degrees, you can always add and subtract more and more and more. So if I really felt like I wanted to, I could sit here and add 10 pi over 5 over and over and over and over and over and over, and every time I do, I'll be finding a coterminal angle to pi over 5. Or I could continuously subtract 10 pi over 5 over and over and over and over, and every single time I do, it's finding a coterminal angle to that pi over 5. So again, coterminal, same ending. All you do is add or subtract a full circle over and over until you get what you're looking for.